All right, let's talk about something we do constantly, probably without even noticing it. We measure stuff. We're always trying to figure out how to take the world around us and, I love this phrase from the source material, slap a score on things. So how do we actually do that?
So, here's what we're going to do. We're basically going to climb this ladder of information. We'll start by defining measurement. Then we'll hit level 1, which is just about names. Then we'll move up to level 2, putting things in order. After that is level 3, where the intervals between numbers actually mean something. And finally, level 4, the absolute zero. Then we'll wrap it all up with the big takeaway. Ready? Let's dive in.
Yeah, this is really the big question, isn't it? How do we turn the world into numbers? How do you take something kind of fuzzy, like, say, reading ability, or something super obvious, like hair color, and turn it into data we can actually work with? Well, it all boils down to two key ideas.
First off, you've got this thing called a variable, and it's exactly what it sounds like. It's anything that can vary or take on more than one value. You know, like a score on a test, your age, even the color of your hair. Pretty straightforward.
And measurement? Well, that's just the act of slapping a label on that variable. And that label can be super precise, like a running time of 10.7 seconds, or it can be a lot broader, like just saying you like or dislike something. Both are forms of measurement.
Okay, so let's get on that ladder. We're starting at the very bottom, the first rung. This is level 1, the nominal level. It's really as basic as it gets.
So nominal actually comes from the Latin word for name, which is the perfect way to think about it. At this level, numbers are literally just names. They're just labels. Think about a sports jersey. Does a player wearing number 23 mean they're better than the player wearing number 10? No, of course not. It just tells you they're two different players.
Let's bring in an example we'll follow through this whole thing. Let's say we have Max, and he's in the Guppies reading group. We'll give that group the number 1. And then we have Aya, who's in the Sharks group, and we'll call that group 2. What do those numbers, 1 and 2, tell us? Absolutely nothing, except that Max and Aya are in different groups. That's it. We have zero clue who's the better reader.
So here's the deal with the nominal level. The categories have to be mutually exclusive, right? You can't be a guppy and a shark at the same time. The values are just categories, not actual amounts. And because of that, this is the least informative level of measurement we have. It's basically just sorting things into buckets. It's like asking, do you shop at Kroger's or Piggly Wiggly? One isn't better than the other, they're just different.
But you know, just knowing things are different isn't always enough, right? We want more information. So let's climb up to the next rung on our ladder. This is level 2, the ordinal level, and this one is all about order. Okay, so the ordinal level takes what we had before, those separate categories, and it adds one super important thing, a meaningful order, a rank. Now we can finally say something is taller than something else, or faster, or stronger. We've got a sequence.
So let's go back to Max and Aya. With an ordinal measurement, we can now say that Max is a better reader than Aya. Awesome! We have an order, we have a rank. But, and this is a big but, we have no idea how much better he is. Is he just a little bit better? Is he way, way better? The ordinal scale is silent on that. That gap in our knowledge is the key limitation here, and it's exactly what our next level is going to solve.
All right, now we're taking a huge jump up in precision. This next level, level 3, the interval level, this is probably the one you'll see most often in fields like psychology and education. Why? Because now the gaps, the intervals between the numbers, finally mean something consistent. So with an interval scale, the distance between any 2 points is always the same. The classic example everyone uses is a thermometer. Think about it. The difference in temperature between 10 degrees and 11 degrees Celsius is exactly the same as the difference between 30 and 31 degrees. Each degree represents an equal unit of heat. The intervals are equal.
And here's a really cool little tidbit from the source material. The word interval actually comes from architecture. Inter, vol, literally means between walls.
Which is such a perfect analogy, right? Just picture a castle tower. The slits for the archers, they had to be equally spaced so they could cover every angle and defend the whole wall. Those equal gaps, those equal intervals, are exactly what we're talking about with an interval scale. So, back to Max and Aya one more time. Let's say they take a reading test, a proper one, scored on an interval scale. Max scores an 82 and Aya scores a 42. Now we can do some real math. We can say with total confidence that Max scored exactly 40 points higher. We finally know the distance between their abilities. That's a game changer.
Okay, we've made it. We are at the top of the ladder, level 4, the ratio level. This is the most powerful, the most informative level of measurement there is. But it has one very special and sometimes very tricky requirement.
A ratio scale has everything the interval scale has. You've got your names, your order, your equal intervals. But it adds the final, crucial piece, a true absolute zero. And we have to be clear here. This isn't just getting a score of 0. This means a 0 that represents a complete and total absence of whatever it is you're measuring. And this is such an important distinction to get. Think about it. If someone gets a 0 on a math test, does that mean they have literally 0 mathematical ability? No way. It just means they did very poorly on that specific test. But what about a temperature of 0 Kelvin? That is a true 0. It's the absolute absence of all heat. And that's what makes it a ratio scale. It's what allows you to say things like, this is twice as heavy or half as long. And it's why these scales are all over the physical sciences, but pretty rare when we're trying to measure complex human things like intelligence or personality.
All right, so we've climbed the whole ladder. We went from just names all the way up to an absolute 0. So what's the big takeaway? Why does all this matter? Let's pull it all together.
So when you put them side by side, how do all these levels really stack up against each other?
This table just lays it out so clearly. Let's walk through it. See nominal, all it has is the name property. That's it. Then ordinal comes along and adds order. Then interval builds on that by adding equal intervals. And finally, ratio gets the whole shebang by adding a true 0. You see that pattern? Each level includes all the properties of the one below it. It's cumulative. And each step up gives you so much more information and statistical power.
And that's really the bottom line here. If you're a researcher, or really anyone working with data, your goal should always be to try and measure things at the highest, most precise level possible. The higher you climb that ladder, the more you know. Now, it's also true that the higher you go, the more complex your measurement might have to be, but the payoff in information is almost always worth it.
So I want to leave you with one last thing to chew on, a little mind bender that comes straight from the source material. We've just spent this whole time ranking these levels of measurement, right? We've been saying ratio is more useful or more powerful than nominal. So which level of measurement are we using when we make that statement? Something to think about. Thanks for joining me.